Okay, so today we're going to move on to a new unit. We're going to start quadratic functions, analyzation of them. Before we were solving quadratic functions in Unit 2, now we're going to start to graph those functions and see different characteristics of them. We've actually already done some of these things in the second unit. I was kind of just sliding them in without actually going too in-depth about them. Now we're actually going to go in-depth. So, the very first thing we need to do is get used to graphing things in our calculator. So let's try graphing these four equations. If you go into your calculator, hit y equals, and you're going to have a whole bunch of y1, y2, and whatnot. What you need to do is graph the first one and then sketch the graph. So x to the power of 2, you graph that in your y equals. You should get a graph that looks like that. Go back into your y equals and put in negative x squared. And you should get a graph that looks like this. Looks pretty similar, a little bit different. If you go into the third one, it's a little trickier. You want to go x squared plus 2x plus 1. You don't need any brackets to make that one work. You can just put it in just as it is. You should get a graph that looks like this. Where that dot is over here. It's just a little bit to the left. And the last one, you want to put in negative x squared plus 2x. So we're losing that 1. And graph again. And we get something like that. I'm going to fix this middle one just because it doesn't look very good. There we go. That's a more accurate drawing. So the question is, what patterns do we notice? Well, if we look at the actual equations, we should recognize these are all quadratic equations. The highest exponent is all 2. We have a b and a c value for some of them. We don't have a c value in others, and we don't even have a b value in a couple of them, but that's okay. What do all of these curves look like? Well, they look like just one big loop, right? This little bump in the road. We actually have a name for that. We call it a parabola. So these are all parabolas. Excuse my spelling if that's wrong. I think it's a U-L-A. That's okay. What else do we notice about these? What do we notice about the x values? So the domain. The domain of every one of these quadratics is the same. It's nice and easy. It's just x is an element of the reals. If we look, that makes sense. That means that x could be any value. And if you put arrows on the end of these graphs, like we should, they would go forever out into the positive x and into the negative x, all the way out to positive infinity and all the way out to negative infinity. What do we notice about the range? Well, what we notice about the range is that it'll only go off into infinity in one way. So if we look at this first one, we're going up into infinity, but we're not going down. We have a minimum. That's the minimum point. That's the lowest it can go. If we look at the other one, we go infinity the other way, but now we have a maximum point. So a point where the graph can't go any higher. And we see the same thing for these other two. That means the range always produces a min or a max. And that's an important thing to know. These are things we're going to be calculating all the time. We also see that we have a y-intercept, and at least one x-intercept in these questions. As we know from working with quadratics, you don't always get an x-intercept. Remember, if we have a discriminant of 0, that gives you 0 solutions. That means there's no x-intercept. So we'll see some examples of that. We always see one y-intercept. There's always a y-intercept somewhere. This is a nice little note page. For any number x, its square. Y is a function of x. This is a quadratic function. That's just a lot of mumbo jumbo. All that really matters is you know that x squared, you're getting a parabola. That's the important thing here. This is a quadratic equation graph. It's a parabola. The shape of the quadratic is a curve called a parabola. Parabola? I think it's an E. I don't know. Okay, that's a good little page for notes if you need to come back. We have something called parameters, and we've always called them other things, but the proper word we should be using is parameters. Those parameters are A, B, and C. They're constant numbers or coefficients that are in front of our x values. These parabolas actually tell us something, believe it or not. So we can look at a quadratic equation and have an idea of how it's going to look before we actually do anything. The A value, the very first value that comes in front of your x squared, that parameter, it dictates whether you open up. So that means you go open up, or if you open down. It also dictates one other thing. It says how wide it is. Meaning that, is it like this, or is it like this? The value affects all of those things. The B value, the parameter B, it's actually shifting the graph left or right. So the B value shifts it left or right. If there is no B value, our graph is just perfectly in the center there. Given whatever the B value could be, it may shift it to the left or to the right. So for instance, that would be shifted left, and that would be shifted right. It's just moving the parabola on the graph. The C parameter is a pretty important one. It tells us lots of things. One of the big things it tells us is it shifts it up or down. And some of you might also have recognized that the C value tells us the y-intercept. We're going to go over that a little bit in a minute here. But the big thing is the C value moves it up or down. So with no C value, we end up right there at the origin as our minimum or our maximum. But it could shift up, or it could shift down, depending on what the C value is. There's a few more terms that you guys are going to have to learn in this unit. I'm going to try to underline them here and go over them. The vertex. Another word for the vertex is the min or max. They call it the vertex because that tells you it could be a min or max. It doesn't say which one it might be. They just say that's either the highest point or the lowest point. They call it the vertex. It's always a minimum or a maximum. In a quadratic equation, there's no other choice. Your vertex has to be a minimum or it has to be a maximum, meaning that there's only ever going to be one lump like this. It'll never lump back like that. Quadratics only ever have one vertex, which means it has to be a minimum or a maximum. The axis of symmetry. Underline that word. That's going to come up all the time in this unit. The axis of symmetry is the line in which the equation is just being mirrored around. So if we look at the second point there, they've drawn in the axis of symmetry. It's right here. And the reason that's your axis of symmetry is that if you took 1/2 of the parabola on either side and you folded it over the axis of symmetry, you made a mirror image of it, you would get the other side of the parabola. So if you took this blue side of the parabola and you folded it over, you would get exactly that green side. What do you notice about the axis of symmetry and the vertex? Hopefully you notice that they cross through each other. So the axis of symmetry always goes right through the vertex. It's going to work that way every time. Your axis of symmetry is a line. If you ever get asked for the equation of the axis of symmetry, you write it as x equals and whatever that value of x where you draw that line is. So if you look at our two questions, wherever this big red dot is I'm drawing, whatever that value of x is, you've drawn a straight line up and down that value. That's all the points where x is equal to some number. So maybe x is equal to 3. That's all the points x equals 3. That's your axis of symmetry. A couple other notes. When the coefficient of x squared, that's the a parameter, when the a parameter is positive, the parabola opens up. So it looks like that. It opens up. It's a cup facing upwards. And its vertex is a minimum point. When the coefficient of x squared is a negative, the parabola opens down. So it looks something like this. And if you look at that, you hopefully see that the vertex is a maximum. The domain of a quadratic function. So that's all the possible x values. We've already talked about this. The domain of a quadratic function is x is an element of the reals, and that's always going to be the truth. It's never changing. Not unless a question has specific restrictions around it. Any quadratic will just have that as its domain. The range of a quadratic function, so all possible y values, the range is going to be either going from minimum, and if it's a minimum point, then it would go from the minimum all the way to infinity. And if it's a maximum, it's going to go all the way from the max, or negative infinity, sorry, to the maximum. Depending on what our parabola looks like. And then 0.7 is written out for you. The y-intercept is always just the parameter c. Whatever your c value is, that's your y-intercept. That's the easiest thing to calculate in the world. Okay, let's look at this. Let's look at an equation, see if we can't figure things out. Analyze the quadratics. So enter them into your calculator, then use the second trace menu. We're going to go over our calculator a little slow here, so listen closely, please. If you turn your calculator on, you go y equals. In the very first one, we're going to do x squared plus 2x minus 3. And then you're going to hit graph button. And you should get a graph that looks something like that. You have to find a whole bunch of things about that graph. You can see them all listed out there on the left. The vertex, the intercepts, the axis of symmetry, the domain, the range, the min, the max. There's lots of things you have to look at. So we need to know how to do that in our calculator. To find the vertex, you want to hit the second button, and then you want to hit trace. So for vertex, you hit second trace. And you'll see something called min or max. In our question, we have a minimum value. See how it goes down to the very bottom? So we want to calculate a minimum value. Click on minimum. On the bottom of your calculator now, it should have taken you back to your graph after you clicked minimum. It says left bound. And if you push the little arrows on your calculator, you'll see you have a little X or a little dot that moves around your graph. Left bound means click somewhere left of the minimum point. So move your little X left of the minimum point and hit enter. Now it says right bound. So go right of the little minimum point and hit enter again. It'll say guess. We don't want to guess. We want to know the exact answer. So hit enter one more time. And it'll tell you that the vertex is at exactly -1, -4. That's exactly the location of our vertex. The next thing we do, x-intercepts. We could do the x-intercepts by hand. If you remember, the x-intercepts, those are just your roots, or your zeros, or your solution to this equation when y equals 0. We could factor that really quickly, and we could find the solution. Or we could use the quadratic formula very quickly and find the solution. And what you would find is that your x-intercepts are at 2, 0, and 1, 0. That doesn't work. Oh, sorry. I factored that too quickly in my head. Let's go back. Those numbers don't multiply to be -3. So we have x minus 1, x plus 3. There we go. Factored that a little too quickly in my head. So we have our answer of -3, 0, and 1, 0. Those are your x-intercepts. There's a way to do it on your calculator as well. So if you go second trace again, you'll get some points that say value, 0, minimum, maximum, X-intercepts are called your zero, so click on the 0 button. And again, it says left bound, right bound, so you can go left bound of your X-intercept. You go left bound of your X-intercept. Either one, doesn't matter which one. I'm going to do the one on the left first. Hit enter, and then go right bound of your X-intercept. So I'm picking this first one right here. I went left bound, so anywhere in this section. And then I went right bound, anywhere in this section. Hit enter. It says guess. We don't want to guess. We want the exact answer. And it comes up and says -3, 0. That's perfect. That's our first one. You can do the same thing, except now go left bound to the point on the right and right bound on the point to the right. So you just have to do that process twice. If you missed how I did that, I graphed my function and then I went second trace and then 0. Click the, not literally the number 0, but the number 2 where the option says calculate 0. Okay, let's do the y-intercept. Who knows what the y-intercept is? It should be your c value. So our y-intercept is just 0, -3. It's whatever your c value is. The axis of symmetry. So what is this line right here? Remember, it shares a point with the vertex. Whatever your x value is from your vertex, that's your axis of symmetry. X equals -1. That's your axis of symmetry. Your domain for this question will always be x is an element to the reals. Your range for this question is going to be y is greater than or equal to, and it's greater than or equal to because we have a minimum point, -4. And y is an element to the reals. And the very last question says, do we have a min or a max? We have a minimum. Quick review. To find the vertex, you go second trace, and then you calculate either number 3 or number 4, min or max, depending on your question. X-intercepts you can solve by hand by factoring them or using quad formula. Or you can use your calculator by going second trace and then clicking 0, which is the number 2 option. Our y-intercept, that's just where our c value is. The axis of symmetry comes from the x value of your vertex. The domain is always x is an element to the reals. The range, y is always greater than or -4, because that -4 is our y value from our vertex. And we have a minimum point, not a maximum. Okay, you can do the second question on your own. Pause the video, try it on your own, and see if you're doing pretty good at this stuff. Okay, let's do one more question over here together. You should have hopefully unpaused this video now. You completed that last one on your own and were able to figure it out or ask people for help. Sorry, someone just came in the room there while I was doing that. I had to talk to them. Hopefully you've done that last question. If you didn't get it, you should have worked with a friend or asked a teacher for some help. If you still don't get it, try to refer back to your notes. If you still don't get it after that, I can help you out sometime during PLT, after school, at lunch. Just make an appointment with me. So, here's a graph. It says graph this. Graph this. And identify all of the missing variables or all the information that it's asking for. So, in your calculator. Very first thing you're going to do. Put it in your calculator. So y equals negative 2x squared minus 6x plus 20. And you can do that without using any brackets. It should work. It probably doesn't fit your screen. If it does, that's great. If it doesn't, make sure you go to your window, and you need your y maximum to be a little bit higher than normal. So I make my y maximum 25. That lets me see the entire graph. When you're deciding on a window, you need to be able to see your x-intercepts, your y-intercept, and your vertex. If your window doesn't fit those things, you need to change your window. Okay, the intercepts. So the x-intercepts, you go x-intercepts. Go second trace. Click 0. Go left bound of the one on the left. So I'm going to do first. Hit enter. Then go right bound of the one on the left. Hit enter. It says guess. We don't want to guess. We want the exact solution. So hit enter again. Your very first x-intercept is negative 5, 0. Do the same thing for the other one. So go back second trace. Click on number 2, the 0 option. We want to go left bound of the x-intercept on the right. Click enter. Now right bound of the intercept on the right. And click enter. We don't want to guess. We want the actual solution. Hit enter again, and you get 2, 0. Those are your x-intercepts. What's your y-intercept? That's the easiest one to calculate. It's your c value. It's 0, 20. Whatever your c value is will always be your y, and it's always 0, that. The vertex goes second trace. We have a maximum, so we want to calculate the maximum. Go left of the maximum point. Hit enter, go right of the maximum point. Hit enter. Hit enter one more time, and your vertex is at negative 1.5, 24.5. The equation of the axis of symmetry. That's a tricky one. There's nothing in your calculator that's going to help you with that. What you need to remember is the equation of the axis of symmetry is from the x value of your vertex. It's this value right here. So it's x equals negative 1.5. That's your axis of symmetry. It'll always be that point on your vertex. Your domain is always x is an element of the reals. That's always going to be the case with quadratics. The vertex of the function, we've already calculated that. That was a mistake. What it should have said is the domain or the range of the function. So range. And that's going to be y, and it's less than or equal to, because we have a maximum point, so y always has to be less than the maximum. And your maximum was 24.5. And y is also an element to the reals. That just means it has to be a real number, but it has to be less than 24.5. And finally, let's sketch our graph. My suggestion is you draw all those points roughly. You want your vertex, your y-intercept, and your two x-intercepts. Draw those dots in, and then connect them all in a nice parabola shape. And that gives you a pretty good estimation of what the graph looks like. Okay, here's another one for you. Pause the video. Work this one on your own. It's all the same type of questions as the last time, so you can rewind, follow your notes, do whatever you need to do to be able to figure this out on your own. Okay, the next thing we need to do is we need to follow a table of values and see if it represents a quadratic equation. So this is a little tricky. I'll do the first one with you. The second one you're going to try on your own. So if you ever get given a table of values, and it says, is this a quadratic equation? That's what the question says. Is this represent a quadratic equation? Your calculator can do this.
Miss Sharp, could you call the office, please? Miss Sharp, call the office, please.
Your calculator can figure this out for you. So what you do is in your calculator, there's a stat button. Look for it. It should be pretty close to the arrows. Mine is right below the delete button. If you click stat, so stat, and then click edit, and you'll get a little thing that comes up, and it says you should see columns like L1, L2, blah, blah, blah. L3, you keep going. All that matters is the L1 and the L2 for us. That represents our X and our Y. You can click in the numbers there. So write in 0, hit enter. 1, hit enter. And then keep doing that. And I'm taking these values from the table of values over here. In L2, use these values. So it's 2, negative 1.5, negative 5, negative 8.5, negative 12. Put all those numbers in your calculator. Fantastic. Now, once you've done that, click Stat again. Takes you back to that list. Go over to Calc. So click the right arrow and go Calc. And then you want to do something called a quad regression. Quad reg. Go click that button and hit enter. If you do that, you should have got, your calculator should come up and say a whole bunch of things. It says y equals ax squared plus bx plus c. And then it says a equals b equals c equals. And those things So if you look at that on your calculator, you should have gotten, it should have said a equals 0, b equals negative 3.5, and c equals 2. That's telling you your actual parameters in that quadratic equation. If your a value is 0, you need to ask yourself, do you have an x squared term? The answer is no. You can't have an a value of 0 and have a quadratic equation. It's not possible. So this first one is not a quad. And I know that's a lot of steps, and that's all new stuff, and that's really hard. So what you need to do is write down those notes really well, and try the practice one right next to it on your own. Take your time, go step by step, and see if you can get it. If you get stuck, work with a friend. And if you and some friends can't get it in a nice little group, you need to come and work on it a little bit after school or during a PLT time. Okay, just about done. The last 2 slides are just a couple word problems. Nothing has changed. And I want you to try those on your own. The only thing I'm going to give you a hint about is that these are now word problems, meaning that your domain and your range have to fit the context. So for instance, this domain cannot be t is an element of the reals. And I use t because in context, the t is your x. That doesn't work because you can't have negative time. So your domain would be t is greater than or equal to 0 because you can start at 0 time. For height, you're going to have the same problem. Your height can't go into the negatives, right? It's not going to go through the ground. I guess maybe if it hit the ground really hard, maybe it creates a little dent. We're assuming it doesn't do that. So our height would just also be greater than or equal to 0. But it's also going to have a maximum. So we need to figure out that maximum point. We should really write this the other way, just for purpose. The height's going to be greater than 0, but it's going to be less than some point. You have to figure out what that point is. Go ahead and try both these word problems on your own. If you finish before the end of class, which you definitely should, there's a practice booklet for you to start practicing your skills.